Let's talk about congruency statements. So first of all, what is a congruent triangle? They're triangles that have the same shape and size, but not necessarily the same orientation. So they could be turned in different ways, but in the all, they'll be the same shape and the exact same size. So because they're the exact same shape and same size, it means that all the corresponding parts are congruent. So the pieces that match with each triangle will be congruent to each other. So for example, here we have an example of two congruent triangles, triangle PQR and triangle LJK. So we can see that the corresponding pieces, like angle P and angle L, will be corresponding angles because they have the same measurement. And angle R and angle K would be corresponding angles because they have the same measurement. And we know that because of how they're marked. Side QP is going to be the same or congruent with side JL. And we know that because of the number of hash marks that are present. So we know those are the corresponding pieces. These have a different orientation. They're turned differently, but they are the same shape and the same size. So non-congruent triangles here. Now we know both of these are equilateral because they all have the same, each triangle has the same sides, and the angles are all 60 degrees, but we can tell that they're not congruent triangles. This one is definitely bigger than the other one. And we can tell that their sides are not the same because this one has one hash mark on each side, which these have two. So where these are congruent to each other, they are not congruent to the sides in this triangle. Okay. So when triangles are congruent, you can actually write a congruency statement that matches all the corresponding parts. So when you're doing this, order matters because the order tells you which pieces, angles, and sides actually match up with each other and which pieces are congruent. So we're going to use this figure from above and we're going to write congruency statements. Now, your congruency statement might look a little different than the next person's, and that's okay as long as the order of the letters tells us where we should go. So, for example, if I want to say triangle, and I'm just going to call it PQR, is congruent to, and when you do the first one, doesn't matter, just pick the letters. But now we have to match it up. Well, we know angle P matches with angle L, so that has to be the first here. Q is going to match with angle J, so that goes here. And then angle R matches with angle K, so that goes here. So from the congruency statement, I'll know that angle P and angle L are congruent, angle Q and angle J are congruent, angle R and angle K are congruent. And I should be able to do that without a picture as well. If I have the congruency statement, I know what angles are going to be equal. But I also know the sides because remember, a side is just denoted by two letters. So if I take two letters, so I know that PQ should be congruent to LJ. So if you look at the picture, side PQ is congruent to side LJ because they have the same number of hash marks. QR would be congruent to JK, and we can see that in the picture. QR has 3 hash marks, JK has 3 hash marks, and so on. But what if you name the first angle different? Well, we can do it a different way. Let's go triangle RPQ. So what if we did triangle RPQ, which is valid. We just have to make sure our second triangle actually matches up. So what matches with R? K. What matches with P, we know is L, and what matches with Q, we know is angle J. So again, even though these congruency statements are written differently, they are both valid congruency statements for these triangles here. Okay? And you could come up with some other ones depending on how you organize the letters in your first one will depend on how you organize the letters for the second one. And if I'm only giving congruency statements, I should be able to tell which angles are congruent, and I should be able to tell which sides are congruent. And that's basically it for the congruency statements.